Hello students, welcome to EPG Padasala. I am Dr. Malavi V, Assistant Professor in Economics, Avinashalingam Institute for Home Science and Higher Education for Women, Coimbatore. Today we will discuss on the topic interpretation. Introduction. Interpretation refers to the task of drawing inferences from the collected facts after an analytical or experimental study. In fact, it is a search for broader meaning of research findings. The task of interpretation has two major aspects. One, the effort to establish continuity in research through linking the results of a given study with those of another. Number two, the establishment of some explanatory concept. In one sense, interpretation is concerned with relationship within the collected data, partially overlapping analysis. It also extends beyond the data of the study to include the results of other research, theory and hypothesis. Thus, interpretation is the device through which the factors that seem to explain what has been observed by researcher in the course of the study can be better understood, and it also provides a theoretical conception which can serve as a guide for further researchers. According to C. William Emery, interpretation has two major aspects, namely establishing continuity in the research through linking the results of a given study with those of another and the establishment of some relationship with the collected data. Interpretation can be defined as the device through which the factors which seem to explain what has been observed by the researcher in the course of the study can be better understood. Interpretation provides a theoretical conception which can serve as a guide for the further research work. Why interpretation? Interpretation is essential for the simple reason that the usefulness and utility of research findings lie in proper interpretation. It is being considered a basic component of research process because of the following reasons. It is through interpretation that the researchers can well understand the abstract principle that works beneath his findings. Through this, he can link up findings with those of other studies having the same abstract principle, and thereby can predict about the concrete world of events. Fresh inquiries can test these predictions later on. This way, the continuity in research can be maintained. Interpretation leads to the establishment of explanatory concept that can serve as a guide for future research studies. It opens new avenues of intellectual adventure and stimulates the quest for more knowledge. Researcher can better appreciate only through interpretation why his findings are what they are, and can make others to understand the real significance of his research findings. The interpretation of the findings of exploratory research study often results into hypothesis for experimental research, and as such, interpretation is involved in the transition from exploratory to experimental research. Since an exploratory study does not have a hypothesis to start with, the findings of such a study have to be interpreted on a post factum basis, in which case the interpretation is technically described as post factum interpretation. Technique of interpretation. The task of interpretation is not an easy job, rather it requires a great skill and agility on the part of researcher. Interpretation is an art that one learns through practice and experience. The researcher may at times seek the guidance from experts for accomplishing the task of interpretation. The technique of interpretation often involves the following steps. Number one, researcher must give reasonable explanations of the relations which he has found, and he must interpret the lines of relationship in terms of the underlying processes, and must try to find out the thread of uniformity that lies under the surface layer of his diversified research findings. In fact, that is the technique of how generalization should be done and concept be formulated. Number two, extraneous information, if collected during the study, must be considered by interpreting the final results of research study, for it may prove to be a key factor in understanding the problem under consideration. Number three, it is advisable before embarking upon final interpretation to consult someone having insight into the study and who is frank and honest and will not hesitate to point out omissions and errors in logical argumentation. Such a consultation will result in correct interpretation and thus will enhance the utility of research results. Number four, a researcher must accomplish the task of interpretation only after considering all relevant factors affecting the problem to avoid false generalization. He must be in no hurry while interpreting results. For quite often, the conclusions which appear to be all right at the beginning may not at all be accurate. Precautions in interpretations. One should always remember that even if the data are properly collected and analyzed, wrong interpretation would lead to inaccurate conclusions. It is therefore absolutely essential that the task of interpretation be accomplished with patience in an impartial manner and also in correct perspective. Researcher must pay attention to the following points for correct interpretation. First one, at the most, researcher must invariably satisfy himself that the data are appropriate, trustworthy, and adequate for drawing inferences. The data reflect good homogeneity and proper analysis has been done through statistical methods. Number 2, the researcher must remain cautious about the errors that can possibly arise in the process of interpreting results. Errors can arise due to false generalization or due to wrong interpretation of statistical measures, such as the application of findings beyond the range of observations, identification of correlation with causation, and the like. Another major pitfall is the tendency to affirm that definite relationship exists on the basis of confirmation of particular hypothesis. In fact, the positive test result accepting the hypothesis must be interpreted as being in accordance with the hypothesis rather than as confirming the validity of the hypothesis. The researcher must remain vigilant about all such things so that false generalization may not take place. He should be well equipped with and must know the correct use of statistical measures for drawing inferences concerning his study. Number 3, he must always keep in view that the task of interpretation is very much intertwined with analysis and cannot be distinctly separated. As such, he must take the task of interpretation as a special aspect of analysis and accordingly must take all those precautions that one usually observes while going through the process of analysis. That is, precautions concerning the reliability of data, computational checks, validation, and comparison of results. Number 4, he must never lose sight of the fact that his task is not only to make sensitive observation of relevant occurrences, but also to identify and disengage the factors that are initially hidden to the eye. This will enable him to do his job of interpretation on proper lines. Broad generalization should be avoided as most research is not amenable to it because the coverage may be restricted to a particular time, a particular area, and particular conditions. Such restrictions, if any, must invariably be specified and the result must be framed within their limits. The researcher must remember that ideally in the course of a research study there should be constant interaction between initial hypothesis, empirical observation, and theoretical conceptions. It is exactly in this area of interaction, theoretical orientation, and empirical observation that opportunities for originalities and creativity lie. He must pay special attention to this aspect while engaged in the task of interpretation. Types of interpretation. Researchers use a similar but more meticulous process to gather, analyze, and interpret data, while experimental scientists base their interpretation largely on objective data and statistical calculation. Social scientists interpret the result of written reports that are rich in descriptive detail but may be devoid of mathematical calculations. Quantitative interpretation. Scientists interpret the result of rigorous experiments that are performed under specific conditions. Quantifiable data are entered into spreadsheets and statistical software programs and then interpreted by researchers seeking to determine if the results they achieved are statistically significant or more likely due to chance or error. The results help prove or disprove hypotheses generated from an existing theory. By using scientific method, researcher can generalize about how their result might apply to a larger population. For example, if data show that a small group of cancer patients in a voluntary drug study went into remission after taking a new drug, after cancer patients might also benefit from it. The analysis of numerical data is represented in mathematical terms. The most common statistical terms include mean. The mean score represents a numerical average for a set of responses. For a data set, the terms arithmetic mean, mathematical expectation, and sometimes average are used synonymously to refer to a central value of a discrete set of numbers. Specifically, the sum of the values divided by the number of values. If the data set were based on a series of the observation obtained by sampling from a statistical population, arithmetic mean is termed the sample mean to distinguish it from the population mean. Standard deviation. The standard deviation represents the distribution of the responses around the mean. It indicates the degree of consistency among the responses. The standard deviation, in conjunction with the mean, provides a better understanding of the data. For example, if the mean is 3.3 with a standard deviation of 0.4, then 2/3 of the responses lie between 2.9 and 3.7. Frequency distribution. Frequency distribution indicates the frequency of each response. For example, if respondents answer a question using an agree or disagree scale, the percentage of respondents who selected each response on the scale would be indicated. The frequency distribution provides additional information beyond the mean since it allows for examining the level of consensus among the data. Higher level of statistical analysis, that is, example, t-test, factor analysis, regression, ANOVA, can be conducted on the data, but these are not frequently used in most program assessments. Qualitative interpretation. Certain academic disciplines such as sociology, anthropology, and women's studies rely heavily on the collection and interpretation of qualitative data. Researchers seek new knowledge and insight into phenomena such as the stages of grief following a loss, for example. Instead of controlled experiments, data is collected through techniques such as field observation or personal interviews of research subjects that are recorded and transcribed. Social scientists study field notes or look for themes in transcriptions to make meaning out of the data. The analysis of narrative data is conducted by organizing the data into common themes or categories. It is often more difficult to interpret narrative data since it lacks the built-in structure found in numerical data. Initially, the narrative data appears to be a collection of random, unconnected statements. The assessment purpose and questions can help direct the focus of the data organization. The following strategies may also be helpful when analyzing narrative data. Focus groups and interviews. Read and organize the data from each question separately. This approach permits focusing on one question at a time. Example, experiences with tutoring services, characteristics of tutors, student responsibility in the tutoring processes. Group the comments by themes, topics, or categories. This approach allows for focusing on one area at a time. Example, characteristics of tutor, level of preparation, knowledge of content area, availability. Documents, code content and characteristics of documents into various categories. Example, training, manual, policies and procedures, communication responsibilities. This approach keeps your information organized and easily accessible. Observation, code patterns from the focus of the observation. Example, behavioral pattern, amount of time, engaged or non-engaged in activity, type of engagement, communication, interpersonal skills. Data interpretation and analysis techniques. The analysis of the data via statistical measures and narrative themes should provide answers to your assessment questions. Interpreting the analyzed data from the appropriate perspective allows for determination of the significance and implication of the assessment. Some data interpretation and analysis tips. Number 1, consider the data from various perspectives. Whatever you project maybe or whatever data you have collected from your business, it's always best to ask what that data means for various actors or participants. Number 2, think beyond the data but do not stray too far from the data. Be mindful that you are not making too much of your data or too little. Make the link between the data and your interpretations clear. Base your interpretation in your research. Number 3, make visible the assumptions and belief or mental model that influence your interpretation. We each carry images, assumptions and stories in our minds about ourselves, others, the organization we work in, etc. As a composite, they represent our view of our world because these models are generally unarticulated, that is below our level of our awareness. If left unexamined, these assumptions and beliefs can lead to incorrect interpretations. Reflect on your own thinking and reasoning individually or collectively. List your assumption about the inquiry focus. Take care not to disregard outlying data or data that seems to be the exemption. 4. Data that is surprising, contradictory or puzzling can lead to useful insights. Basic analysis of quantitative information. Number 1. Make copies of your data and store the master copy away. Use the copy for making edits, cutting and pasting, etc. Number 2. Tabulate the information, that is add up the number of ratings, rankings, yes or no's for each questions. Number 3. For rating and ranking, consider computing the mean or average for each question. For example, for question number 1, the average ranking was 2.4. This is more meaningful than indicating example how many responded ranked 1, 2, 3 or 4. Number 4, consider conveying the range of answers. Example, 20 people ranked 1, 30 ranked 2 and 20 people ranked 3. Basic analysis of qualitative information. Number 1, read through all the data. Number 2, organize comments into similar categories. Example, concerns, suggestions, strength, weaknesses, similar experiences, program inputs, recommendation, output, outcome, indicators, etc. Number 3, label the identify patterns or association and causal relationship in the themes. Example, all people who attended programs in the evening had similar concerns. Most people came from the same geographic area. Most people were in the same salary range, and what processor or events respond and experience during the program, etc. Number 5, keep all commentary for several years after completion in case needed for future reference. Let us summarize. Interpretation is an integral part of any research. Attempts should be made to put the information in proper perspective. Example, compare results to what you expected results, original goals, especially if you are conducting a program evaluation. Indications of measures of accomplishing outcomes or results, especially if you are conducting an outcomes or performance evaluation. Description of the program's experiences, strength, weaknesses, etc., especially if you are conducting a process evaluation. One should record conclusions and recommendation in a report and associate interpretation to justify your conclusion or recommendations.